Hello, how are we doing today? There's been a request to do a free response problem, Unit 3, Part A. So I am going to go through that with you. All right, so now the camera spinning and go like that. All right, so here's what we have. Sorry about the way these all look. I just got them from the AP website, and it's hard to tell what the question is. This is not necessary. All these things, it's supposed to be done on digitally through the website. I printed them all off, scanned them, and gave them to you. So it's kind of messy the way they are laid out. So anyway, this one is, here's our function. It's important to note that it is a twice differentiable function. If it's differentiable, then it has to be continuous in order for it to be differentiable. So we'll use that in part C for sure. What's the value of g prime of 3? They've defined our g to be f of x squared minus x. So g of x equals f of x squared minus x. So if we're going to find the derivative of g, it would be the derivative of f of x squared minus x. So that would require the chain rule. So derivative of the outside. So f prime of x squared minus x, leave the inside alone. It's just to the derivative of the outside. And then times the derivative of the inside, which is 2x minus 1. So that is the derivative of g. In part A, we want to find g prime of 3. So we just 3 squared minus, so that's 6 times 5, and f prime of 6 from the table. All right, f prime of 6 is 4. So 4 times 5 gives you 20. All right. So in part B, it says it is known that g prime of 0 is negative 1. What is the value of f double prime of 0? All right, so we're going to find the second derivative of g. Oh, you want to see my finger? There's from the Band-Aid. Look at how nicely healed up it is. Still a little tender, but yeah, it's still attached. All right, so we know that this is my first derivative of g. So g double prime would require a product rule. So first one times the derivative of the second one plus the second one times the derivative of the first one. The derivative of f prime of x squared minus x. Derivative of the outside is f double prime. Leave the inside alone. Times the derivative of the inside, which is 2x minus 1. I'm glad they picked 0. We're trying to find g prime of 0, or double prime of 0. So that becomes f, if I plug 0 in, f prime of 0 times 2, negative 1, f double prime of 0 times negative 1. All right, so we can figure out, well, they tell us g double prime of 0 is negative 1. F prime of 0 from the table. F prime of 0 is 2. And negative 1 times negative 1 is just 1, so plus f double prime of 0. So f double prime of 0 is negative 5. All right, and then part C says, boy, they sure do like the intermediate value problem, or intermediate value theorem. So this is just another one of those. So is there, for part C, If c is between 0 and 3, and is there a point where the function is 5 in that interval? So what you need to figure out is what g of 0 is and what g of 3 is, and if 5 is in between them. We know the function g is continuous. I'll explain that here in a second. So let's figure out what g of 0 is. G of 0 is f of 0 squared minus 0. So it's the same as f of 0. So mark chart. F of 0 is 4. All right. So our first, it's between 4 and something. So now let's figure out what g of 3 is. That's the same as f of 3 squared minus 3, so that's f of 6. F of 6 is 7. All right, so we do have our 5, which is in between 4 and 7. So we still haven't answered the question. The answer to the question is it's got to meet two criteria. This number has to be between 4 and 7, which it is. But g has to be continuous. Well, we know f is continuous. That's given because f is differentiable. It's actually twice differentiable. So we know that f is continuous. Well, g is f of x squared minus x. Well, we know x squared minus x is continuous because that's just a parabola. So if we do f is continuous and x squared minus x is continuous, the composition of two continuous functions must also be continuous. Okay, if you plug one continuous function into another continuous function, by definition, the result is continuous. So if g is continuous, this is between 4 and 7, then you would say intermediate value theorem guarantees that it does exist. All right. That concludes my lesson on number 1 from Unit 3 anyways. If there's more questions, I'm happy to do more videos. Let me know.